Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem allocate minimum pages. So the problem statement says that given an array of integers where each element represents the number of pages in the ith book, you also have an integer k representing the number of students. The task is to allocate books to each student such that each student receives at least one book. Each student is assigned a contiguous sequence of books and no book is assigned to more than one student. And the objective is to minimize the maximum number of pages. So here we can see the pattern is like minimum of uh, max of min. So we can see a min of max. Okay. So we have to minimize the maximum number of pages, and we know whenever this kind of problem comes where we have to find max of min or min of max, we can apply binary search. So uh, here we have to minimize the maximum number of pages assigned to any student. In other words, out of all possible allocations, find the arrangement where the student who receives the most pages still has the smallest possible maximum. And if you are not able to allocate books, we can return -1. So we can see in the input we are given an array. These array are just the books, and the ith element here tells us that how many pages are there in that book, and k here represents the students, and we just have to allocate books to students such that the such that the student who is getting the maximum number of pages should be minimized. So I will explain through example also, and let me take the same example, this example one only. So here the array is given 12, 34, 12, 34, 67 and 90, 67 and 90. So this we can see that array is given. It means that total 4 books are there, and all the 4 books have this number of pages, and number of students are just I think 2. So we have to distribute these books to 2 students, these 4 books to 2 students, such that the student which is having maximum number of books should be minimized. So you all know that there are many possible ways to distribute these books. So let's say this is student 1 and this is student 2, and yes, we have to keep these rules in mind while distributing, that each student must receive at least one book. It means each student should have at least one book, and each student is assigned a contiguous sequence of books. It means that we have to distribute books in a contiguous way. So it means like when we are distributing books to student 1, we should distribute books to student 1, then only we should move to student 2. Also, if we are distributing, then we should distribute in a contiguous way uh, in the name of students also, and on the basis of these uh, order also, that this array which is given. So first we have to distribute 12 pages of book, then this, then this, then this. So how many possible ways are there? So let's say, and the third, we should also think that no book is assigned to more than one student. That it's obviously that if we assign one book to student, how we can assign the same book to another student? So it's already understood. So the first possibility, that we we have to assign at least one book to each student. So the first possibility, that we assigned him student 1 12 pages of books, and then we assigned him or we can say then student 2 we assigned all the books 34, 67 and these 90. And the second possible way, we assigned him these 2 books, and these 2 books we assigned to student 2. And the third possibility, we assigned him 3 books contiguously to student 1, and then the last book, that is of 90 pages, we assigned to student 3. And we can see that there is no other possible cases there, because if we try to assign all the books to student 1, then student 2 will be having no books. So but we, in the according to rule, we have to assign at least one book to each student. So we can see there are three possibilities. Now we have to calculate how many pages students are getting. So here student 1 is having, in the case 1, student is having 12 pages, and student 2 is having these number of pages, 34 plus 67 plus 90. So here it is also written in the explanation that sum is coming 191. So the sum is coming 191 here. It means that the student is having, in the case 1, if we distribute the books like this, then the student with the maximum number of books is student 2, and that number of pages are here 191. 191. All right. And in the case 2, 12 plus 34 will be 56. 46. It will be 46. All right. And here 0 plus 7, 7, 9 plus 6, 15. So here the student which is having maximum number of books is max of 46 and 157. This is coming 157. And here also it was already written 157. And here if we sum all these three things, so this will be 113, and here 90 is, and so maximum of 113 and 90 is what? 113. Wait, I have to write in square bracket here. So here it is coming 113. Now our task is to choose that possibility where we can minimize the maximum number of pages. So which case is minimum? So we can see this case is minimum. So we have to choose this case, and what we have to just return, we have to return the, what we have to return, this with this integer only, the maximum number of pages only we have to return. So we have to return 113. So we can see the answer is also 113. Output is 113. And if we cannot allocate books, we have to return -1. So how we cannot return any book? Let's say number of books are n and number of students are k. And here in the problem it is given that we have to assign at least one book. So let's say if number of books are less than the number of students, so in that case we will return -1. All right. Otherwise we can just find out all the possibilities and just find the minimum of them. So how we can solve this? So we know that the problem is like minimize the maximum number of pages, uh, min of max. So we can think of binary search also. But before that, how we will approach this problem? So first of all, the observation, we have to find the observation. So what is the minimum possible answer? What is the minimum possible answer we can get? So what do you think that what can be the minimum possible answer? So I'm thinking that let's say total n number of books are there and exactly n number of students are there. So if we assign exactly one book to each student, then what will be the answer in that case? So the answer in that case will be the book with the maximum number of pages. So the answer will be just the maximum element present in the array. So the minimum possible answer will be the maximum element present in that array. And what is the maximum possible answer which we can get? So the maximum possible answer we can get is, let's say, what we can do, let's say, how we will think of it, how we will find the maximum possible answer. So answer is just the maximum number of pages a student is having. So let's say in a case there is only one student and total n number of books are there. So it means that we have to assign all the books to only one student. So it means that the answer in this case will be the sum of all the elements in the array. So in this case, the maximum will be the sum of all the elements in the array, and we can easily see the constraints also, that size can be 1 also, and it can go up to 10 to the power 3, and number of students can also be 1. So this can be our possible minimum and possible maximum answer. So it means that our answer will be in between this minimum and maximum only. So what we can do, we can just apply a binary search to find our answer between this minimum and maximum possible answers. So our in the starting min and max, or we know these are our low and high, and what's our mid, we have to find out. So in the starting, if I talk about this example only, so what's our minimum possible answer? That is the maximum element present in the array, that is 90. 90, yes. So the minimum possible answer is 90, and what is the maximum possible answer present is the sum of all the elements. So sum of all the elements will be what? 191 plus 12. If we sum all of this, we have to just find the sum of 191 plus 12. That will be around 191, 201, and 203. So maximum will be 203. So now we have to find mid. So in this case, the mid will be what? Low plus high by 2. So 90 plus 203 by 2. I am opening calculator. So let me find out 90 plus 203 divided by 2. So our answer is in this case 146. Now we have to find out, we have to just check, is this the possible answer? Is this the possible answer? And if this will be the possible answer, then we can store that answer somewhere. Let's say our result, we can store that result somewhere, and then what we can do, in the starting we can also take -1, and then if we find the answer, and we have to find the minimum possible answer, so we can also move to the left side to reduce our answer. Understood? So first of all, what we have to do, that we will check that this 146 is our possible answer or not. So first of all, how we will verify that this 146 is a possible answer. So what is 146? The 146 means that a student is having maximum number of pages as 146. So what we can do, we can call a function of let's say we can call a different function, let's say is possible, and there we can just check, we can pass this 146 and all these required uh, array and that number of students. So what we can do, we can just check that whether this 146 is possible or not. It means the maximum number of pages a student is having should not exceed 146. So what was our array? Our array was, I should copy this array thing. So what is our array? I am writing here. So our array is 12, 34, 67 and 90. Now in the starting, the number of students I am taking as 1, and the number of pages I have allocated to the student 1 is 0. See, number of students is starting from 1, so we can take the first student always, that I am allocating in the starting as as him the 0 pages. All right, and now what we can do, we can iterate through a for loop through the whole array, and what we can do, that we can check that can I allocate him this number of pages? Can I allocate him this number of pages such that the number of pages should not exceed 146? If the number of pages is exceeding 146, then what I will do? Then I will call another student and give him that book. All right. So what I will do? First of all, I will check that if the number of page he is having, if I add the number of pages of the current book, then is it exceeding our is it exceeding our 146? Is it exceeding our 146? So in this case, if it is exceeding, so first of all I should talk about if it is not exceeding and it is in the range. So if it is in the range, then what I can do, I can assign him this book, because the number of pages, maximum number of pages should be 146 only. So I can assign assign him, and I will say that increase the number of pages he is having with array of I, no problem. All right. And in the else case, if it is exceeding 146, then I will say, okay, now you are done, because number of pages cannot exceed 146. So I will call another student and I will increase the another number of count of students, and also I will reset the page, because the now the new student is having only ith book. All right. Now when I will complete my iteration from this for loop, then I will get some number of students here that I have counted, and if this student count is coming greater than our given student count, then we will just return false, because we have only k number of students. So in that case we will return false, and in the else case we can return true. All right, we can return true in the else case. So now if I dry run also, we can easily understand the cases which we have written. So in the first case, my minimum was 90, maximum was 203, mid was 146, and now we have to check, can this will be my possible answer. So in the first iteration, I will just check number of pages as 0, and pages plus in the first iteration, pages plus 12. So if my number of pages plus 12, that is 12, is less than 146, yes. So it means that I can assign 12 pages to student 1 only. So now I will increase it, and now again 12 plus 34, that is 46. So 46 is also less than 146, so I can assign him this 46 number of pages and no problem will be there. Now coming to the third book, number of pages are 67, so this is 113, and 113 is still less than 146. So now we can assign these number of pages to student 1 also, student 1 only, and then if I go and try to assign 90 pages book to student 1, then this will exceed, this will be 203, and we cannot assign him, because we have we have to check for 146 only. So I it means that I have to call a new student and just reset my page to array of I, that is assign him 90 pages book. Now in this case I can see that we need two students, we need two students. So here if we distribute books such a way that maximum pages a student is getting is less than equal to 146, so in that case we need two students, and we were having two students only. So it means that this 146 case is possible, so we can return true. So now my result will be now 146, and I will store this result. And as the problem is saying that we have to minimize the maximum number of pages, so we will try to find for the less possible answer also. Now what I will do for trying to find the more uh, we if we try to minimize our answer, what we can do, we can move to the left, we can reduce our mid. And how we can reduce our mid? We can just say that my maximum will be now what, 145, mid minus 1. Now my new mid will be what, 90 plus 145 divided by 2, this will be 117. So my new mid will be 117. And now again I will reset it to 0. And yes, also this will be 117 now. Again, number of pages I can see that if I assign 12 number of pages, and this will be 117. So yes, this is true. And then the next book will come. I can assign him. Then it will be 113, and we can assign, because this is one less than 117. And then for assigning the 90 pages book, we need to call a new student, and we will reset it. Now after completing the iteration, we will check how many students we are getting, how many students do we need. So we need two students. Yes, it's true, because we were having two students, so we will return true. So my new minimum possible answer is what, 117. Now again we will try to find the minimum possible answer, and we will again reduce the mid. So now my new mid will be 116, new high will be 116. And now my new mid will be what? My new mid will be 90 plus 116 divided by 2, 103. Now first of all I will reset all these things. All these things I will have to reset it again and again, again and again. And what was it? 103. 103. Now, can I assign him 12 pages of book? Yes. Can I assign him 46 pages? Yes. Can I assign him 113 pages? No, because this will be greater than 103. So we need two students. Then I have to reset it to 67. Then 67 plus 90, 157. I can't assign. I need a new student. Then I will reset it to 90. Now here, in this case, we need total of 3 students, but we already have only 2 students. So we will return false here. So this will be we cannot find. So what we should do? We should move right, obviously, because we need to reduce the number of students, and to reduce the number of students, we need to increase our number of pages limit. We have to increase our number of pages limit. So we have to increase our mid now. So to increase our mid, what we will do, we will go on to the right side, and to move to the right side we will increase our minimum to 104, mid plus 1. And now my new mid will be what, 104 plus 116 divided by 2. So this will be 110. Now again I have to reset them. So I have to reset them, and again my new mid is 110, and my pages are initially 0. Can I assign him 12 number of pages? Yes. Can I assign him 46 pages? Yes. I cannot assign him now total one 113 pages, because this will be greater than 110. So I need a new student again. Then can I assign him 157? Because 67 plus 90 will be 157. I cannot assign him. So I need a new student. So now I will reset it. Now still we can see that 3 is coming greater than 2. So this here again we will return false. So now we will not update our mid now. Again we have to move to the right. We will increase our mid to 110. Wait, what was earlier? 110 was earlier, and now we have to update our mid to 100 and minimum to 111. And now my new mid will be divided by 2, 113. Now again doing the same thing, 113. So here, now what? Can we assign him 12 pages of book? Yes. Can we assign him 46 pages of book? Yes. Can we assign him 113 pages of book? Yes. Can we assign him 90 if he submit 203? No. So we need a new student, and then I have to reset it. So yes, at the last we get two students which is coming into our range. It means that we can return true and we will now update our answer to 113. And now we found the answer. Now we can also minimize it, and now again I will go to the left and reduce my mid to find a new minimum possible answer if we can. So now my new minimum, a new high will be, see, we have to move to the left side. So now I have to reduce my high, that is mid. Wait, I got confused. If we have to move right side, then my high will be equal to mid minus 1. Wait, we have found the answer and we have to reduce our mid. So now my new high will be mid minus 1. That will be 112. 112. So many cases are there, that's why. So now my new mid will be what? 111. And now if I check for 111, we can see that we can assign, we can, we can, wait, I should erase this. But I think that it's already clear because we have solved it many times. Yes, 12, yes, 46, 130, 13 notes. So we need a new student. And then again 67 plus 90, 157. No, we need again a new student. So here we are getting three students. So it means that it is greater than k. So we will return false. And now if it is returning false, it means that we have to increase our limit. So we will move to the right side. And to move to the right side, this will be now this 112. And now my new mid will be also 112. And now again we will check for 112 because we are in the range. And now can we assign him 12 pages? Can we assign him 46? Can we assign him the next book? No, we need to increase. Again, can we assign him 157? No, so we need to increase it. So here also three students we will need, but we have only two students. So we will just say that return false. And now we have to increase our limit. So my new minimum will be 113. And my, before finding the mid, we can see that my low has exceeded high, but our low should be less than equal to high. Then we can only go to the binary search. But we can see that our range is getting, we can see that our low is getting now greater than high. So now we will stop here, and we can see that we can just return our answer now, that is 113. But why to store this another variable at as a result as 113? We also can see that our answer is coming at low. This was our low and our answer is now coming at low. So we can also just simply return low also. We have seen now. Now if I go and just implement this, and we have found our answer as 113, and the output is also 113. So now if I go and just implement it, so first of all I will find the size of the array. Then what I have to do, I have to find the low. Low was what? The maximum element present in the array. So the maximum element present in the array we can find by using this STL function. and now my high will be the sum of all the elements. So we know STL functions, we can use them, and yes, we are summing it, so we should take long. So I will just use long only. Here also I will try to use long. And now what I have to do, I have to just call the binary search low less than equal to high. Then I will find mid. Mid will be what? Low plus high minus low by 2. Then we will check that this our possible answer, that is this mid, and we can also pass our array, and also I am passing the size, and also I am passing the number of students also. And if it is possible, then we can say then just go and check for the more minimum possible answer, reduce high. And now in the else case, you can go and increase the limit, and now at the end we can just return our low only. And yes, we have to return the answer as integer, so we can return the integer answer also. But in the starting I will also check that number of students is coming less than the number of books, then in this case I will return -1. And now just I have to write the function of the bool function is possible. I have to just write this function, and here I'm passing some things. So those things were long, mid, and this array, and this integer n, and that integer k. So many things we were passing, and now I can just store a variable student, and pages he is having, that is initially 0, and then we can just iterate the to the array, and just check that to how many students we can allocate if we have our limit as mid. So first of all we have to check that if I allocate him this book, is it in the range? If it is in the range, then allocate, no problem. And if it is not in the range, then just call a new student and assign him that book of array of I. And also at the last check number of student, if it is coming greater than k, simply return false, else we can return true. And now we are good to go to compile and run and check whether we are able to pass this one test case or not, and then submit it and just check whether we are able to pass all the test cases or not. And we can see that we have solved this problem successfully. And now if I tell you about the time and space complexity, so we can easily see that we are using binary search. So first of all, time complexity will be log of what the range, this high minus low approximately. And in every binary search we are calling this is possible function, and here this is taking we can see that we are using a for loop here, which is of total n size. So also this will be into n. So the time complexity will be big of log of range into n, wherein is the size, and range is from low to high. And space complexity, we can see that we are not taking any space, so space complexity is big of 1. So this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.